Hi, Professor. My topic is system of perception, location, and gripper of objects to be implemented in a robotic arm in real conditions. My motivation, a large part of the industries of developing countries cannot be at the level of production of the powerful countries due to the lack of optimal industrial automation. One of, one of the greatest contributions to process automation is the implementation of robotic arms. The incredible flexibility and adaptability that these machines have contributes in a very significant way to industrial automation. And therefore, it's necessary for industries with low production to work with this technology. As can be seen in the figure, the lack of industrial automation is reflected in the consumption of gross domestic product. Latin America countries such as Argentina and Colombia are far below power countries such as Japan and South Korea. Robotic and automated process in general represents a considerable increase in the economic profits of a company. The cost of acquiring automated machinery may be much higher than workforce labor, but in the long run, production is worth the expense and far exceeds human capacities to produce and generate income. As can be seen in the future, forced labor costs are much higher compared to robot costs since the beginning of 21st century. Speaking specifically of robotic arm, there are reasons why industries don't see it a viable means of growth. One of the most important reasons is that most of the jobs that could be automated involve an uncontrolled environment with a high probability of changing the process conditions. For example, as seen in the figure in a construction company, the environment and work conditions are constantly changing. The best option would be cooperative work between human and robot and to increase productivity and reduce the amount of labor required. However, to achieve this result, the robotic arm needs to have some kind of perception system to interact and grasp different objects in different environments. Background. Object perception technologies already exist, but the research did not go outside the industries that develop this type of work. On the other hand, there are simulated alternatives or studies that simply remind our research work. A report on the estimation of solutions for the three-dimensional detection of objects tell us about new technologies such as RGBD cameras that, in addition to color, are capable of perceiving depth. And additionally, we at LiDAR technology, which use infrared sensor, we can optimize depth perception of an object. These new technologies generate several methods to fulfill the task of object perception. Another work proposed a simple and scalable detection algorithm. This will improve that average precision by more than 30% in relation to previous results from 2012. Thus, it will achieve an average precision of 53%. His approach works with two main ideas. First, high-capacity convolution neural networks can be applied to bottom-up region approach to locate and segment objects. For second, when labeled training data is sparse, supervised training for an auxiliary task, followed by domain-specific fine-tuning, and yields a significant increase in performance. A research work by the company CloudMind Technologies show us how a precision system would be applied by detecting grip points and detecting the location of the object combined with 6D position estimation. The authors propose to merge all these methods with deep learning and thus achieve a robotic gripping system. Another interesting report tells us about a new approach to grip planning of 3D objects based on geometric hand-object matching. The goal of this method is to build a contact score map on visualization of 3D objects and apply this score map and the kinematic parameters for a hand to find a set of target contacts on the surface of the object. Finally, it's important to mention a recent investigation of the Universidad Católica Boliviana by Reinaldo Esteban Cruz Villagomez on robot grasping. It shows an investigation of deep learning methods and perception technologies to achieve a simulated object grasping system in the ROS work environment. My problem statement, the lack of perception system for robotic arms influence the low industrial automation for developing countries. A robotic arm can have a lot of freedom of movement, but without a system that collaborates with its works, the possibilities are very limited. A robotic arm could be programmed for a repetitive job on a production line, but if there was a fault or gap in the products that reach the robotic arm, it could cause a ruckus that ends creating more losses than profits. There are many works environments where a robotic arm could considerably increase production by replacing labor. However, most of this environment works with unfavorable conditions for a machine that only follows a fixed path with a preference for a controlled environment. My proposed solution to implement a system of perception, location, and grasping of objects in the KUKA robotic arm of the Universidad Católica Boliviana in order to demonstrate its functionality and thus expand the variety of works possibilities for a robotic arm within the industrial automation of companies in developing countries. My steps set an object depth perception method, establish a complete object detection and segmentation system, define an object location system with depth data, define a deep learning architecture to distinguish objects for the rest of the environment, train a detection system to grab objects, and evaluate the complete system of perception, location, and grip, and make a comparison with the proposed solution. That's all, profession, and this is my bibliography.